Do you know the Mercury sound? I found one guy's video that shows that if you speed up and then reverse the Mercury sound, you'll hear some strange voices. So, I want to prove it myself. So I found another video that has the same sound from 12 years ago, and then I downloaded it. But I thought, doing it directly is too easy, so I'll observe the spectrogram, because doing this we are learning something new. Here we are on Virtual-EN S3, a spectral synthesizer that is completely free for your PC. I'm loading the waveform of the sound and resetting the default settings of the project, and I'm adjusting the pixels per bit speed to 16 so I can easily speed it up to 8 times. There's the spectrogram of the sound. As you can see, it's a really long sound, it's longer than 1 minute, so I'll play this part that is really interesting. If you want, you can skip it. Okay, now let's analyze the spectrogram, and first of all we can see that there are really low frequencies, and this helps us understand that this is something low pitched. And secondly, we see those sorts of lines equally distant, and this is called a harmonic ratio. In particular, it's a harmonic ratio of a human voice. Do we agree on that? Because you must agree. Of course. But now we are queuing to another problem. Yes, let me explain. Here's a representation of the wave of a tone. As we can see, it's 10 seconds long, and let's see what happens if we change its speed. It stretches, and not only the time is different, also the frequency adds its definition. And now let's see what happens if we do the same with the synthesizer. Here we can only change the speed of the player and the pitch separately. So if we change the speed, only the time changes and not the frequency, because it still plays the same sample. If we change the pitch, we can only change the frequency, as the player needs the same time to play this sound. So, if you want to do the same thing I've just done with the wave on the synthesizer, you have to adjust both speed and pitch. Now we understand what I have to do. I have to raise the image, so what can I do? I'm adjusting the guides to the highest frequency I can see, and then using the selection tool that is magnetic to the guides, selecting all the spectrogram. Now I have to cut it. Fine. Placing the guides to the 8 times frequency, like here. Place the top of the selection and paste it. And here we are with the 8 times pitched spectrogram. Now, what I have to do? Place the player at the end and increase the speed by 8 times, so 128 pixels per bit. I can play now the spectrum from one side to the other in reverse with the reverse play button here. Let's hear. Funny, huh? Now, I know that the sound quality of the audio you've heard is really low because it's only an approximation of the frequencies. I'll play the audio I made using an app doing the same I've done here. Let's go. By the way, the Mercury sound is not the original one recorded by NASA. That sounds completely different, but I haven't analyzed it yet, so let me know in the comments if you want me to do it. See you in the next video. Bye!